This is Babitha, working as Assistant Professor in the Department of EC in Institute of Aeronautical Engineering. In this session, I am going to discuss about different definitions as well as terminologies which are going to utilize in the MOSFET circuits. So in this MOSFET circuits module, we are going to discuss about the FETS, that is field effect transistors. So different types of field effect transistors. Here we are having two types of FETS, junction field effect transistor as well as metal oxide semiconductor field effect transistor. So in these two types of FETs, we are going to discuss about what is the construction and operation and the VI characteristics of both the junction field effect transistor as well as metal oxide semiconductor field effect transistor. And along with that, we are going to discuss about small signal equivalent circuits of all the JFETs as well as MOSFETs. And we are going to discuss about gain, input and output impedances from that small signal equivalent circuit. And the same small signal model we are going to see for all the types of amplifiers in the FETs. Those are common source amplifier, common gate amplifier and common drain amplifiers. And from these amplifiers, we are going to calculate the parameter called transconductance. And along with the small signal equivalent model, we are going to see the high frequency equivalent circuits of both the JFET as well as MOSFET. So overall, we are going to see the in detail description of both the junction field effect transistor as well as metal oxide field effect transistors in this particular session. So here, what is mean by FET? So FET is nothing but a field effect transistor. So in short form, we are calling it as the FET. Okay, so this particular FET is a 3-terminal device. So that particular 3 terminals are gate, source as well as the drain terminals. So as like in the case of bipolar junction transistor, in the case of field effect transistor also we are having gate, source and drain terminals. So in this particular FET, the current conduction is due to the only majority charge carriers. That is nothing but, and that is also depending upon the how much amount of voltage we are applying to its gate terminal of the FET. Okay, so that's why it is called as the voltage controlled device. FET is called as the voltage controlled device. Why? Because it depends upon the applied input signal or input voltage only. It can able to generate the current within it. Okay, so what are the basic functions of 3 terminals of the FET? We will see now. Source. The first terminal is the source. It is a terminal through which the charge carriers entered into the channel. Through the source terminal, the charge carriers, the majority charge carriers will enter into the channel here. Drain. The second terminal is the drain terminal. So, by using this particular terminal, the charge carriers are leaving from the channel. And what about the gate? The gate terminal controls the conductivity between the source and drain terminals here. Okay, the current conduction between the channel is controlled through the application of the voltage across the gate terminal here. Okay, and here FET is called as the unipolar device. Why? Because conduction is due to the only majority charge carriers. That may be the electrons or holes. It depends upon which type of material we are utilizing to design the FET here. And second one is what is mean by JFET. JFET is nothing but the junction field effect transistor. So it is also a 3-terminal semiconductor device. And in this particular JFET also, current conduction is due to the majority charge carriers only. That may be the electrons or holes. So that's why it is called as the unipolar device or unipolar transistor. So the 3 terminals of the JFET are again source, drain and gate. Okay, source is used to provide the charge carriers to the channel, and drain is used to leave the charge carriers from the channel, and gate is used to control the charge carriers within the channel through source and drain terminals. So unlike in the case of bipolar junction transistor, in the case of junction field effect transistor, it is the voltage controlled device. As here the potential applied at the gate terminal controls the drain current here. The output current in the FET is any kind of FET, that may be the junction field effect transistor or metal oxide semiconductor field effect transistor or normal field effect transistor. In all the cases, the output current is the drain current which is flowing through the drain terminal. So this particular drain current is directly proportional to the how much amount of voltage we are applying across the gate terminal here. In some cases, whenever we are providing the gate voltage is also zero, the voltage applied between the drain and source terminals also can able to generate the current. But in any ways, in both the cases, we are applying the voltage only, not the current. So that's why it is called as the voltage control device. But in the case of BJT, the current conduction is due to both the carriers, that may be the majority carriers as well as the minority carriers. And always the output current is proportional to the input current in the case of BJT. Suppose if you take the common emitter configuration of the BJT, the output current is the collector current. Always this output current is increase or decrease depends upon the base current which is flowing through the input terminal of the common emitter configuration. So because of this reason, it is the current control device. The output current is controlled by the input current in this particular case. But in this particular case, the output current is controlled by the applied input voltage. So that's why it is the voltage control device. And BJT is the current control device. And next, what is mean by metal oxide semiconductor field effect transistor? MOSFET is nothing but metal oxide semiconductor field effect transistor. Okay, so in the case of MOSFET, instead of 3 terminals, we are having 4 terminals here, that is source, gate, drain and body terminals. But in most of the cases, we will tie both the source as well as body terminals and we will make it as normal source terminal here. So that again it is having source, drain and gate terminals. So we can indicate by using 4 terminals or 3 terminals in the case of MOSFET. Okay, it is also one type of the transistor and we can utilize these for the analog circuits as well as the digital circuits design. So the function of all the FETs are same here. Those can be utilized for the amplification as well as for switching purpose. Next, what are the other names for metal oxide semiconductor field effect transistor? The other name for MOSFET is called as IGFET. IG is nothing but the insulated gate field effect transistor. In the case of MOSFET, the gate terminal acts as the insulator between the channel as well as the gate terminal here. So that's why it is called as the insulated gate field effect transistor. Next one is what is mean by input impedance. So the input impedance of any circuit we can define here it as the ratio of input voltage to input current here. Okay, that is nothing but V in by I in. That is nothing but the input resistance. So generally this input resistance we will measured in ohms and we will indicate with RI and the units of this one is ohms. So this may be available in kilo ohms or mega ohms. What is mean by output impedance? So output impedance of a particular circuit is defined as the ratio of output voltage to output current here. So this is we are indicating with R0 and this one also measured in ohms here. So next one is define pinch of voltage. So this pinch of voltage concept will occur in the field effect transistor. So what is mean by pinch of voltage is nothing but it is the voltage at which the channel is pinched off. Channel is pinched off means generally in the case of FET, we are having the source and drain terminals like this. So in between source and drain terminals, the channel is existing here. Okay, the channel is existing between the source and drain terminals. So the channel pinching off is nothing but the length or width of the channel is decreasing here. Okay, the length and width of the channel is decreasing here. That is depends upon how much gate to source voltage we are providing. Okay, how much gate to source voltage we are providing for the FET, as well as how much drain to source voltage we are providing for the FET here. Various. So depends upon the drain to source voltage and gate to source voltage, the width and length of the channel is changing here. But in most of the cases, the length of the channel is depending upon the drain to source voltage only. If the drain to source voltage is increasing means the number of charge carriers will attracting towards the source terminal from the drain terminal here. Okay, so if it is attracting towards this source terminal means, so the charge carriers are reducing in the channel here. So once the charge carriers are reducing means the channel will reduce like this. So it is pinched off here. The channel is pinched off here. That is nothing but all the free charge from the channel get removed. This amount of charge carriers all are removed from the channel here. Okay. So at pinch of voltage, the drain current becomes constant. That is nothing but ID will become IDSS here. Whenever the channel is pinched off. So when it will pinched off means whenever the voltage reaches to the pinch of voltage, the applied VDS voltage reaches the pinch of voltage, the channel will pinched off. So whenever the channel is pinched off means the drain current will become constant here. And next, define transconductance. So the transconductance we will indicate with GM. GM is nothing but transconductance, and it is the ratio of output current to the input voltage. It is the ratio of output current to the input voltage of any active device here. In this case, we are considering the FET here, field effect transistor. In the case of field effect transistor, it is the output voltage by input current. Because of that reason, we are calling it as the transconductance. Why? Because one parameter is from output side and one more parameter is from input side. So in that case, we can call it as the transconductance. Normally, conductance is nothing but current to voltage, but it is transconductance. Why we are calling it as the transconductance means output current is from the output side of the circuit and the voltage is from input side of the circuit. Because of that reason, it is called as the transconductance. And next one is define drain resistance. So drain resistance we are indicating with small rd here. So we can define this drain resistance. It is the ratio of change in drain to source voltage in the FET to the corresponding change in the drain current in the FET. And when it is happen means whenever we are maintaining the gate to source voltage as some constant value. By keeping the gate to source voltage as some constant value, and if you vary the drain to source voltage, the corresponding change we can expect in the drain terminal. So that variation we are indicating with the del ID. So the drain resistance in the is nothing but the variation of the drain to source voltage to the variation of drain current whenever the gate to source voltage is constant in the FET. And next, what is an amplification factor? So amplification factor we will indicate with mu here. Okay, it is this amplification factor indicate it is the rate of change of drain voltage VDS with gate voltage VGS with keeping ID constant. That is nothing but it is the variation of drain to source voltage to the variation of gate to source voltage whenever the drain current is constant. So that indicates the amplification factor, that is the amplification of the applied gate to source voltage. And next, define ohmic region. So ohmic region is the one of the operating region of the FET here. Okay. So this we can see in the characteristics of the MOSFET or FET. Okay. So here it is a linear response in current from changes in the voltage. It is called as ohmic region or linear region because JFET behaves like a voltage controlled resistor in the ohmic region. Why? Because in this particular ohmic region, the response of the FET is like this. That is nothing but this is the input voltage and this is the drain current. Okay. So as VDS increases linearly, the ID current is also increasing in this particular region. So till here it is the ohmic region. After that you will get it as the some constant value or saturation current. So this particular region we are calling it as the ohmic region. So in this particular region it acts like a voltage variable resistor. FET acts like a voltage variable resistor or voltage controlled resistor. And next, give classification of field effect transistors. So these field effect transistors are divided into two types here. That is junction field effect transistor and metal oxide semiconductor field effect transistor. So what is the basic difference between junction field effect transistor and metal oxide semiconductor field effect transistor is, in the case of MOSFET, the oxide layer is present between the metal and channel terminals here. But in the case of junction field effect transistor, there is no oxide. That oxide means silicon dioxide layer will not present between the metal and channel here. That is the basic difference between both the JFET and MOSFET here. So these junction field effect transistors are available in the depletion mode. And these metal oxide semiconductor field effect transistors are available in depletion mode as well as the enhancement mode here. And what is the basic difference between the depletion mode as well as the enhancement mode here? It is, in the case of depletion mode, the channel physically exists between the source and drain terminals of the FET here. But in the case of enhancement mode transistor, there is no physical channel exist between the source and drain terminals. Because of the application of the input voltage, the movement of charge carriers will be done between the source and drain terminals. Because of that movement of the charge carriers only, the channel exists in the case of enhancement mode. But physically, there is no channel between the source and drain. So that is the basic difference between the depletion mode as well as the enhancement mode. So here it is physical, channel is present, and there is no physical channel in the case of enhancement mode. So here silicon dioxide layer will be present in the MOSFET. And this depletion MOSFETs are available in two types. Those are N-channel MOSFET and P-channel MOSFET. And similarly, the depletion MOSFETs are also available in two types, N-channel as well as P-channel. And enhancement MOSFETs are also available in N-channel MOSFET as well as P-channel MOSFETs here. So how we can differentiate whether the particular MOSFET or JFET is belongs to the P channel or N channel is depends upon in the N channel JFET or in N channel metal oxide MOSFET. In all the cases, the substrate is the P type of semiconductor material. So once the substrate is P type of semiconductor means the channel existing is the N channel MOSFET. And while in the case of P channel FETs here, in all the cases, the substrate material is the N type of semiconductor material. So once the substrate is the N type of semiconductor means obviously the channel is opposite to that, that is P type of semiconductor material or P type of charge carriers will flow in the channel, that is holes. Holes are the majority carriers in the P channel and electrons are the majority carriers in the N channel FETs. So these are the different types of FETs. And what is mean by P channel junction field effect transistor? So here in the case of P channel junction field effect transistor, the name itself indicating the channel is composed by the holes of charge carriers. Okay, the channel is existing due to the majority charge carriers, those are holes here. Okay, that is nothing but when the transistor is turned on, so primarily the movement of holes which constitute the current flow in the device. Okay, the majority charge carriers in the P channel are holes. So that's why the movement of holes will generate the current in the P channel JFET. So this P channel JFET is also composed of 3 terminals. Those are source, drain as well as gate terminals. And next one is what is mean by N channel junction field effect transistor. So N channel JFET is a JFET whose channel is composed of primarily electrons as the charge carriers here. Why? Because N type means electrons are the majority charge carriers. So in this particular N channel JFET, the current conduction is due to the electrons or movement of electrons in the channel. So this particular JFET is also consist of 3 terminals: gate, source as well as drain terminals. And next one is what is mean by P channel metal oxide semiconductor field effect transistor. So P channel MOSFET is one of the classification of the MOSFET or semiconductor type of device. So it consists of N substrate in the middle with light doping concentration. I have already mentioned whenever we are designing the P channel MOSFETs, N type of substrate we will utilize to design that. Okay, and it is also a 3 terminal devices and it is a unipolar device and it having unipolar characteristics because its operation is depends upon the majority charge carriers, those are electrons here. So what is mean by N channel MOSFET? So N channel MOSFET is also one of the type of the metal oxide semiconductor field effect transistor. So in this case, the majority carriers are the electrons. Okay, so the movement of electrons in the N channel MOSFET will give the current conduction in the device. So that's why these are called as the current carriers here. So whenever the MOSFET is on state, the majority charge carriers or the movement of the majority charge carriers will give the current flowing in the device or through the channel. So next, what is mean by amplifier? So the amplifier is a device which is used to amplify the applied input signal here. So it will amplify the applied input signal without changing its frequency here. That is nothing but it will improve the amplitude of the signal. It will not vary the frequency or phase characteristics of the signal here. That is the basic function of the amplifier. So this amplifier we can design by using any JFET or by using any MOSFET. So three types of amplifiers we are having: common source amplifier, common gate amplifier, and common drain amplifier that may be available in JFET form or MOSFET form. And what are the terminals of junction field effect transistor? So for any junction field effect transistor that may be depletion type or P channel or N channel, the terminals are source to generate the charge carriers or to enter the charge carriers into the channel, and drain to leave the charge carriers from the channel, and gate is used to control the charge carriers between the source and drain terminals. And next one is why do you call FET as field effect transistor? Why it is called as field effect transistor? Here it is means, in the case of FET, the current conduction or current controlled by an electric field applied to this. That is nothing but VGS voltage. Whenever we are applying the VGS voltage or VDS voltage to the FET, then only we will get the drain current in the FET. That may be any type of FET here. Okay, so this VGS voltage or VDS voltage we are applying externally here. Okay, external voltage we are applying to the gate to source junction or to the drain to source junctions here. So the field effect, because of the application of the electric field, it is affecting in the device. That is nothing but it is providing the current. So that's why it is called as field effect transistor. And next one is why FET is called an unipolar device. See here, the operation of the field effect transistor depends upon the flow of majority charge carriers only. That may be the holes or electrons. So because of that reason, we are calling it as the unipolar device. It is not a bipolar device. In the case of bipolar device, the current conduction is due to the majority carriers as well as minority carriers which are present in the device. And next one is define small signal amplifier. This name itself indicating small signal amplifier is nothing but it can able to amplify the low frequency signals or low range of signals here. In this particular case, it can able to amplify only few microvolts of the signals those will captured from the sensors. So if we apply high voltage to this particular kind of small signal amplifiers, they may not provide the proper amplification here. And what are the applications of the field effect transistor? So FET generally we can utilize for the buffer application. Why? Because the basic advantage of the FET is it is having very high input impedance and very low output impedance. These are the basic requirements for any amplifier device or any practical applications. So because of that reason, FET we can utilize basically for the buffering here. And we can also utilize field effect transistors in RF amplifiers, in FM tuners, and in the case of communication equipments for the low noise levels. In all these particular cases, RF amplifiers and FM tuners and in the communication equipment, we can utilize this field effect transistors. Okay. Next one is why the input impedance of field effect transistor is more than that of a bipolar junction transistor. See, if we take both the BJT, bipolar junction transistor, and the field effect transistor here. See, in the case of bipolar junction transistor, the input junction is or input side is forward biased. Okay, input junction is always forward biased in the bipolar junction transistor. So because of that reason only the input current is generating in the bipolar junction transistor. So because of that input current only, the output current will be generating in the circuit. The amplified version of the output current we can get across the output of the BJT. But in the case of FET, the input junction is always reverse bias. So once the input junction is reverse bias means the input impedance is very high. If we take in the ideal case, almost it is infinity, but in the practical case, we will get very large value. But in this case, ideal value it is 0, but in the practical case, we may get some low value here. So because of that reason, FET is having very high input impedance compared to the bipolar junction transistor. What is meant by gate to source threshold voltage of a field effect transistor? Okay, so threshold voltage is nothing but the voltage at which the channel is completely cut off and the drain current is completely, it is 0, is called as gate source threshold voltage, and it is also called as VGS off. That is nothing but here the drain current in the FET or MOSFET or JFET is depending upon the applied gate to source voltage only. But here we are maintaining VGS off is nothing but we are not providing any potential to the gate to source junction here. So whenever we are not providing any gate to source voltage means the channel is completely in the cutoff region. That is nothing but there is no movement of majority charge carriers in the channel. So there is no movement of charge carriers means there is no drain current in the device. So at that instant, the voltage of the gate to source, we are calling it as the VGS off or gate source threshold voltage of a FET. And next one is why N-channel FETs are preferred over the P-channel FETs here. See, in the case of N-channel FETs, if we see the charge carriers in both the P-channel MOSFET as well as in the N-channel FETs, if we see the charge carriers, the movement of charge carriers. In the case of N-channel FET, the mobility of the charge carriers means the movement of the charge carriers is about 1300 centimeters square per Vs. But in the case of P-channel FETs, the mobility of the charge carriers is about only 500 centimeter per Vs here. So almost 800 difference is there here. That is nothing but the mobility of electrons in the N-channel FET is very high. The mobility of holes in the P-channel FET here. So because of that reason, N-channel devices are faster than the P-channel devices. And also the N-channel transistor or N-channel FET is having lower on resistance compared to the P-channel FET. And also the gate capacitance for this same diarrhea, it is having a very low resistance, very low input resistance as well as very low gate capacitance in the case of N-channel FET. So because of this reason, we are preferring the N-channel FETs compared to the P-channel FETs. The number of charge carriers are more, the movement of charge carriers is more, and those are faster, and the input impedance is less, and the capacitance of the device is very high. So that's why N-channel FETs are more preferable compared to the P-channel FETs. And next, what are the different types of MOSFETs here? Metal oxide, field effect, transistors. There are two types of MOSFETs. Those are depletion type MOSFET as well as enhancement MOSFET. In the case of depletion type MOSFET, if we take one particular MOSFET, that may be the P channel or N channel, here we are having the substrate, and here we are having the source and drain terminals, and upon this we are having the silicon dioxide layer, and after this we are having the gate terminal. So on this particular MOS structure, whenever the channel is present, whenever the physical channel is present means those belongs to the depletion type MOSFETs. But in some cases, we don't have any physical channel here. Only source and drain terminals are there. We don't have any physical channel between the source and drain terminals here. So those kind of MOSFETs are called as the enhancement type MOSFET. But in this case, the existence of channel is due to the application of gate to source voltage as well as drain to source voltage. When we apply these particular voltages to MOSFET, there is a movement of charge carriers in the substrate as well as source and drain terminals. Because of that movement of charge carriers are accumulated near the source and drain terminals, that charge carriers form like a channel here. And next one is what are the types of enhancement mode MOSFETs. So here we are having two types of enhancement mode MOSFETs. Those are the N channel E MOSFET and P channel E MOSFET. So in this particular case also, if you want to design the N channel MOSFET, we have to take the P type of substrate here. That is nothing but P type of semiconductor material. On this, we have to indicate source, drain and silicon dioxide layer and then gate terminal. So the channel existing whenever we are applying the voltages is called as the N channel here. That is nothing but electrons will form near the source and drain terminals here. But in the case of P channel MOSFET, to design this, we have to take the N type of substrate. Opposite to this channel we have to take, that is source, drain, and upon this we are having silicon dioxide layer as well as gate here. So in this particular case, because of the application of the gate to source voltage as well as drain to source voltage, there is a movement of charge carriers. That is nothing but the holes will accumulate near the junction or between the source and drain terminals. So this is the P channel. So because of this reason, it is the P channel as well as N channel E MOSFETs. And next one is what are the types of depletion mode MOSFETs. So the depletion mode MOSFETs are also two types, N channel as well as P channel MOSFETs. That is nothing but to design this N channel MOSFET, again we have to take the P type of substrate, and in this case there is a physically channel exist between the source and drain terminals. And in the case of P channel MOSFET, to design P channel depletion MOSFET, we have to take the N type of substrate, and there is a physical channel exist between the source and drain terminals. That is the P type of charge carriers will flow in that particular channel. And give the drain current equation of junction field effect transistor. So the drain current equation ID is equal to IDSS. IDSS is nothing but the drain current is at saturation level into 1 minus VGS by VP whole square here. VGS is nothing but the applied gate to source voltage, and VP is nothing but where the channel is pinched off. That particular voltage is called the pinch off voltage. So this is the drain current equation in the case of JFET. And what are the special features of field effect transistor? So while coming to the special features of this field effect transistor, its operation depends upon the flow of majority charge carriers only. So here there is no requirement of minority charge carriers, and that's why we can call it as the unipolar device. And we can easily fabricate these kind of field effect transistors, and it occupies very less space in the integrated form or in the IC form, and it exhibits very high input impedance, mostly in mega ohms it will give. So it is the very big advantage of the field effect transistor. It is providing very high input impedance compared to the bipolar junction transistor. And on the ICs also it is taking very less space, and we can easily and in simpler we can fabricate these field effect transistors in the IC forms. Next, list the advantages of field effect transistor. First main advantage I have already mentioned, it is having very high input impedance, and it will provide a very high degree of isolation between the input circuit as well as in the output circuit. In most of the cases, in the isolation purpose, we will utilize this FETS, and it is very less size, and it is having longer life and very high efficiency. These are the basic advantages of the field effect transistor. And next, what are the main drawbacks of the field effect transistor? So the main disadvantage of the field effect transistor is it is having very small gain bandwidth product in comparison with the normal bipolar junction transistor. So gain bandwidth product is very less, means it can able to amplify very less range of frequency signals only. For the remaining signals, it will provide the distortion as well as noise here. That is the drawback of the field effect transistor. And next, list the various types of analyses associated with an amplifier circuit. So if you take any particular amplifier circuit, we can able to perform the DC analysis, small signal analysis as well as AC analysis. While performing the DC analysis, we are not taking any AC signals into consideration. And similarly, when we are doing the AC analysis, we will short circuit all the DC supplies as well as capacitors in the circuit. And next, what are the parameters of the junction field effect transistor? So the main parameters of the junction field effect transistors are, it will provide the drain resistance from the characteristics as well as transconductance GM and current amplification factor mu here. These are the basic parameters of the JFET. And next, why the input impedance in FET is very high in comparison with the bipolar junction transistor. I have already mentioned, in the case of FET, the input junction is always reverse biased. Because of that reason, the input impedance of the field effect transistor is very high. But in the case of bipolar junction transistor, input junction is always forward biased. So that's why the input impedance is very low in the case of BJTs. And why is FET preferred as a buffer amplifier here? Why? Because why we are preferring the FET for the buffering applications means it is providing very high input impedance as well as very low output impedance. Those are the requirements for the buffering as well as amplification purpose. Because of that reason, in most of the cases, FET we are utilizing here it as buffer. Next one is, what is IDSS? IDSS is the saturation drain current whenever the gate to source voltage for the FET is 0 here. That is nothing but whenever VGS is equal to 0 and depends upon the drain to source voltage only, there is a existence of the current in the FET. But that particular current is the constant current, IDSS. Okay. If we vary the VGS voltage only, again there is a variation in the IDSS here. And next, write the relationship between the various FET parameters. So here, the current amplification factor mu is equal to drain resistance into transconductance. So this is the basic relation in the case of FET here. And next, what are the applications of MOSFETs? So generally MOSFETs we can utilize for the inverting purpose as an inverter, and we can able to utilize these MOSFETs to designing the digital circuits, and it can be used as the high frequency amplifier circuit. These are the different applications of the metal oxide field effect transistor. Normal FETs are used for the buffering purpose. These are for generating the waveforms, as well as for high frequency amplification we can utilize these MOSFETs. And next, what are the advantages of common source amplifier? So the advantage of common source amplifier is having high input impedance and low noise output here. Okay, these are the basic advantage of the common source amplifier. So because of that reason, in most of the cases will prefer this common source amplifier for the amplification of the small input signals. And what are the disadvantages of common source amplifier? So the frequency response of this common source amplifier is very less, that is limited. This is the major drawback of the common source amplifier. And the amplified output voltage can be applied to either a common drain circuit or a common gate circuit. Directly we cannot give or we cannot drive the output of the common source to any practical application. By utilizing other configuration, that may be the common drain or common gate amplifiers only, we can able to apply the output of this to the practical applications. That is also one of the drawback of the common source amplifier. And what are the applications of common source amplifier? So generally it is used for the amplification of the sensor signal, that is nothing but whatever the signals generating from the sensors, and also used for the low noise amplification of radio frequency signals. And in the communication systems like televisions and the frequency modulation receivers, we can utilize this. And we can also utilize as the voltage control devices in the operational amplifiers. And most of the cases used as the cascade amplifiers and RF amplifier circuits. In the cascading purpose as well as radio frequency amplification circuits, we can utilize this common source amplifier. And next, what are the advantages of common drain amplifier? So the common drain amplifier is nothing but the source follower circuit, and it can able to provide very high input impedance and low output impedance, so that we can utilize for the buffer amplifier. We can utilize it for the buffering. And in the case of bipolar junction transistor, emitter follower will be there in the bipolar junction transistor. The same kind of operation we can expect in the case of source follower or common drain amplifier here. Okay, so this particular common drain amplifier itself provides a very high level of buffering as well as very high input impedance. What are the disadvantages of common drain amplifier? So it is, even though it is providing a very high input impedance and a very low output impedance, but it is providing the non-linearity here due to the body effect as well as poor driving capability of the input signal here. So non-linearity and poor driving capability are the disadvantages of the common drain amplifier. And next, what are the applications of common drain amplifier? So these common drain amplifiers again utilized for the voltage buffers to drive the small output loads in multi-stage amplifiers as well as in other voltage gain related circuits. And next, what are the advantages of common gate amplifier? So this common gate amplifier is used for the current buffer amplifier. Though it is having small input resistance, whenever it is having small input resistance only, it can able to run the current buffer, and it is having very large output resistance. So these common gate amplifiers provides very high power gain for the small signal amplifiers. And next, what are the disadvantages of common gate amplifier? So the basic disadvantages are low input impedance and high output impedance. These are the undesired parameters for the amplification. Always for the amplification, input impedance must be high and the output impedance must be low here. So, but even though it can be able to provide very high voltage gain, but the current gain is very less. So because of that reason, the overall power gain is low in this case compared to the remaining FET circuit configurations. And what are the applications of common gate amplifier? So these common gate amplifiers generally we can utilize for the radio frequency amplifiers. In that we can utilize for very high frequency as well as ultra high frequency RF amplifiers, where the low input impedance allows accurate matching to the feeder impedance, which is typically of 50 ohms to 50 ohms or 75 ohms. That is nothing but these common gate amplifiers are used to provide the impedance matching between the stages in the multi-stage amplifiers. So these configurations also improve the stability. That is nothing but it will not vary the variations of the output signal. What is the major difference between the bipolar junction transistor and field effect transistor? So generally this bipolar junction transistor and field effect transistor both are the active semiconductor devices. BJT is nothing but bipolar junction transistor and FET is nothing but field effect transistor. And these two are available in different packages based on their operating frequency and current levels, voltage levels as well as power rating levels here. And these type of devices allows high control over their work. And these both BJTs and FETs are used for the switching purpose as well as amplification purpose in various electronic circuits. But these all are the similar kind of features in the case of BJTs and FETs. But the only major difference here it is in the case of bipolar junction transistor, the current conduction is due to the majority carriers as well as minority carriers. But in the case of field effect transistors, the current conduction is due to the only majority charge carriers. That is the basic difference between the FET as well as BJT. And next, show the symbols of junction field effect transistor. So this is the symbol for P-channel junction field effect transistor. The current conduction is outside the gate. This is the drain, source and gate terminals. And in the case of N-channel JFET, the current direction is inside the circuit here. Gate, drain and source. This is the difference between the P-channel and N-channel JFETs. And next, show the symbol of depletion MOSFETs. So in the case of MOSFETs, we are having 4 terminals: source, drain, substrate and gate terminals. This is gate terminal. Okay. So here in most of the cases, this substrate and source, we will make it as the single terminal. And there is no gap here between the drain and source here. And in this case, the current conduction is towards the gate. And in the case of P channel, the current flow is outside the channel or outside the gate here. And next, show the symbols for enhancement MOSFET. So if we observe the depletion MOSFET and enhancement MOSFET symbols, here there is a gap here between the drain and source and substrate terminals. That indicates there is no physical channel exist in the case of enhancement MOSFET. But in the case of depletion MOSFET, there is a physical channel existing between the source and drain terminal. So that's why we are indicating with the solid line. But here there is a gap between the source, drain and substrate terminals. And next, what is channel length modulation in the case of metal oxide field effect transistor? So in the case of MOSFET or any device, the resistance of the channel is always inversely proportional to its width as well as length here. So the width and length of the channel is varying means the resistance is inversely varying here. So that is nothing but the length of the channel is decreasing here means, okay, decreased here means the resistance of the channel will be varying here, so that the current conduction in the channel will be increases here. So that is nothing but channel length modulation means the saturation region drain current will increases slightly as the drain to source voltage is increases. When the VDS voltage is increasing, the drain current is also increasing. That is due to the reducing the resistance of the channel here. And mention the capacitances of MOSFET. Here we are having 2 types of capacitances are existing in the MOSFET. Those are the gate capacitances and junction capacitances. So gate capacitances are existing between the gate and source, that is CGS, between gate and drain, that is CGD, and between body and gate, that is the CGB capacitance. And Next, junction capacitances are CSB capacitance as well as CDB capacitance those are between the source, body as well as the drain terminals of the MOSFET. And next, what is the basic difference between the depletion type MOSFET as well as enhancement type MOSFETs? So in the case of depletion mode MOSFET, those are turned on at zero gate voltage. So such devices are used as load resistors here. But in the case of enhancement mode, the common switching element, MOSFETs with enhancement modes are the common switching elements in most of the MOSFETs. So these devices are deactivated at zero gate voltages and can be switched when we apply the gate voltage to the gate to source junction. So that is the basic difference. And one more difference here it is, in the case of depletion MOSFET, there is a physical channel already exists between the source and drain terminal. And in the enhancement MOSFET, there is no physical channel exists between the source and drain terminals. In this session, we discussed different definitions as well as terminologies which are utilized in the MOSFET circuits. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.